In this lab, we're going to use gas laws to calculate the molar mass for butane gas that's found in a lighter. So we're going to need to know several different things before we collect our butane gas. First, we need to know our temperature. So we have a thermometer that reads in degrees Celsius, and it's going to tell us that our temperature is 21.0 degrees Celsius. That's going to have to be converted to Kelvin before we can use it in our gas law problem. Next, we need to know the pressure of the gas that we're going to be collecting. We're going to assume that that's going to be the same as the pressure in the room. So what I did is I just used weather.com and I Googled Glenn Gardner, and it tells us that the pressure is 29.99 inches of mercury. That means we're going to have to do a conversion from inches of mercury to centimeters of mercury to millimeters of mercury before we can use that value in our gas law problems. Next, we need to know what the water vapor pressure is at 21.0 degrees Celsius, since when we collect our gas by displacement, there will be some water vapor in our bubble. So if we look up 21.0 on this table, it tells us that the water vapor pressure will be 18.663 torr, or millimeters of mercury. That value is going to have to be subtracted from our corrected value in order to get the pressure of just our butane gas. The next thing we need to do is find out what the initial mass of our lighter is, because we're going to take our lighter and let out some of the butane gas, measure the mass of the lighter after that butane gas has been let out, and we'll be able to figure out what the mass of our butane gas is. So we'll take our lighter, we'll put it on the balance, and our mass is going to be 20.83 grams. So now what I have is a flask that's filled with water. It's been turned upside down, and it's in a bucket of water. And I'm going to take my lighter. I'm not going to light the lighter, but I'm just going to hold the button down, and that's going to let my butane gas out. And what I see are bubbles rising up in my flask, and those bubbles are butane gas bubbles. And I'm going to continue to let that butane gas out of my lighter until I've collected 500 milliliters of butane gas. All right, so this has been going for a while. I'm pretty close to 500 milliliters. So I'm just going to have a couple more bubbles come through here. They're going to displace the water out of the flask, and then we'll see how much gas we produced. Give a couple more bubbles coming through. And the more gas we collect, the smaller our errors will be, the less significant they'll be. So that's why we wanted to collect a lot of gas. So let's see where that meniscus is. Need a couple more bubbles. And again, all I'm doing is just holding down the little lever on my lighter, letting the gas out, displacing the water in my graduated cylinder until the bottom of the meniscus is right on that 50 milliliter mark. So now I have 50 milliliters of butane gas in my graduated cylinder. So now that the lighter has been dried off, we'll put it back on the balance and we'll record our final mass, which is 19.74. So we can figure out the mass of the butane gas that we let out. The volume that we collected was 500 milliliters. We're going to correct our pressure to millimeters of mercury without the water vapor pressure. We're going to convert our temperature to Kelvin, and then we'll be able to calculate what the molar mass of our butane gas is. So go ahead and do those calculations. Look at the possible formulas for butane gas and see if you can figure out what the formula for butane gas is.